annoying banner.
I think this would like give a very vague prompt to the
Yes,
AI.
I think so.
So I think we should mention each and every step, like what the code should do.
Yeah,
Or
we'll
she
ex
did perfectly. I don't know. Okay, you can try. That's why it's
okay,
up to you.
we will try a different prompt. We'll see what we can come up with. Atharva, try
Yeah.
explaining that we are actually writing a code for a game where we have three investors investing in three companies. 0.2, 0.3, 0.5 is the probability distribution for winning of those companies. Yeah.
Okay.
And we'll explain it the entire game.
I think it is like bad at handling long text. So I think we'll
Okay.
give it like small
Right,
steps
right,
of what to do. Like
right.
create three companies, A, B,
I
C.
actually felt the same thing when I was trying out Git Copilot in VS Code. The longer the prompt was, the more inaccurate the code was. So, Nishan, you have Git Copilot as well, right? Try writing a code for it with Git Copilot with a different prompt. We'll have three codes. We'll be able to verify our observation as well.
Yeah, Bob, why don't you write it just like this thing itself? It might be able to understand it. The same thing like create a miniature stock market. It just has the
Oh,
above companies in this.
no, no, it will probably will not be able to grasp the entire context of it. Uh, am I right, Atharva?
Yeah. I think we should give it like very clear stepwise
Correct.
instructions.
Right.
Then only
Hmm.
uh,
I think it's best to program here. As you're programming line by line, you can use Git Copilots. Otherwise, this may not really work in my if I can guess. Anyways, see if you can
yeah.
get lucky.
I think 20%, 30%, 50% is still sort of point to.
Uh, okay. Oh, okay. Uh, 20. Uh, is there any way we can like automate investments of M also?
Investment, automate investment.
Yeah,
You can do that for, I think, one of the investors, the person who's investing away from the distribution. For the others, we'll have to keep, we have specific investments in mind, right? So we have
Yeah.
to the third investor will always invest equally. So the first investor will always invest very close to the actual distribution. So that's the
Okay, so I'll briefly maybe talk on the lines of what me and they were discussing the other day. So Debasmith, you were saying that you would like to start investing with equal probability and then move that towards the distribution that you're getting using the historical data,
Yeah, it's
as you discussed. Because there's no history at all from ground zero,
Yeah.
right?
So it's like a Bayesian approach, right? So when I have no information, we call that a pre-existing knowledge. We have studied in starts too. That's my prior. I'll keep it 1/3, 1/3, 1/3. Then I'll observe the data. Then let these two integrate. So what we call as likelihood. So when you integrate that, you get posterior likelihood, and you would start to see that whoever is the winner, let's say in the first round, B is winner, then I'll move more to B. Then I'll take away weights from A and C. And this process will keep repeating. And let's say we do it 100 times and we see that B is winning 40. So B would have taken out more weight. So it will kind of start converging in that process. How much that is determined through.
No, but imagine everybody plays that strategy. Right? That's the naive question that one can ask there. It's an obvious, it results in an obvious flaw that everybody should be accumulating money, which means commonsensically speaking, nobody accumulates money. Okay, everybody's money comes back. Maybe that's the point of convergence, where there is no change at all. Everybody has the same amount of money.
Correct.
Right? But then if one person deviates from there, he will suck up everything into his bank balance, his account, right? So he will be the richest in no time if he deviates slightly. When everybody is uniform, one deviation will lead to making a lot of money. Okay, so at least some 5 to 6 nice questions one can ask on this problem. This is one such question. Okay. Second is, why to start with the uniform distribution? What advantage does it have? Why not start from some distribution and then slowly converge? Right? Can someone mathematically show that equal distribution is the best strategy to begin with?
So maybe I can try because my answer is that only that is what it is going to my code. But anyway, I may try in explaining why.
Yeah, Sriram, try and get back to us. Not a problem. Okay. Next question is, when there are many people and you, by the way people are playing, that's visible to you. By the way people are playing, if you blindly follow the richest person's strategy, will you make money? Is the question. Let's assume that only one person follows the richest person's strategy. Now that we have 3 people, it's easy for us to replicate this onto some 30 people in no time, right? Once the code runs for 30 would be easy. What will happen if you simply follow the richest person's strategy, the one who has more money right now? Right? Will that be good? Right? Okay. More questions you people can come out with. I of course have more questions, but I don't want to give you, put words into your minds. You generate some ideas. Let's see. Any more ideas? I have 2 more, which I can put forth once you people give me the ideas.
So this game has actually 2 aspects. One is one dimension is what others are doing, essentially the players or competition, right? The other aspect is actually the market, which is basically which stock is winning or not, right? So these are the 2 fundamental dimensions. And as the process goes on, the players react to the market movement, and then you see who is winning or losing, and you start following players. So in other words, how much to react to a fundamental market move versus how much to react to the other players. That will also determine your success.
Okay, correct. So maybe partially that, partially this, once that, once this, something like that we can always do, right? That's called mixed strategy in game theory. All right. Okay. So also please note that if the distribution is known to you all, then what is it that you will play? Investing everything in the highest possible outcome is actually of no use, because if once the low probability even occurs, all your money gets washed away. All right, that's basically the biggest fallacies of stock market. Right, you don't know. See, you open any mutual fund, it will be like 40%, 50%, returns in 1 year. But then that is the return so far. Right, that itself is a fallacy. That then everyone starts investing there, and that's no more 40%. It will quickly drop to 20%. All right. So, what kind of a strategy will you use? Ultimately, with this, can we infer what is quote unquote the strategy which will always work? Is there one? If there is one, right? A lot of interesting things. Yeah, go ahead. Let's see what Atharva has to give us in his code as an observation. This code alone will tell you. You can just play around this code, and today or tomorrow, the moment this code is over and you have good understanding of what is what, I will teach you the Bayesian learning's derivation of this very problem. Mathematically, we'll derive and see what is happening here. Right? It's very eye-opening. Yeah, on to you people.
So one thing is, once we know the distribution of the winning of each individual stock, then basically it boils down to optimizing the weight or the investments you would make in each of them. So you will win if your dot product of your investments with the winning probabilities of the stocks is maximized.
So will that be sufficient? Will that be sufficient? Because here in the game, the person who's winning, his chances of winning or the amount he wins, the returns, not only depends on how much that he has, what percentage of his capital he has invested in that particular company, but also it also depends on how much others have invested in the winning company as well. So say I invest 10% of my company, 10% of my capital, but others have invested very little, say 5%, but their 5% is more than my 10%. Now they own more shares of that company, so the returns will be according to that as well.
Yeah, if we plot the returns of these three companies in a three-dimensional space, if you can visualize, right? So let's say, and then and the x-axis, y-axis, and z-axis is basically the percentage of investment you make or whatever it is, right?
Right.
So you get a vector, right? That is the winning vector. The guys, when you invest, all your weights are actually a vector. The vector that is closest or least angle with the true optimal actually wins. I mean, if we use the knowledge of what we have discussed so far, right? So that means intuitively, if that vector is kind of our eigenvector, if your projection of what you have invested is highest, so the projection will be highest when you are pointing in the same direction, right? We know that it will be only, otherwise you'll actually, will lose some value, right? So intuitively, that is, so in other words, is it related to what others do, or is it fundamentally what the distribution is? Right. So the way I look at it is, you may start with something, W vector, which is away from the eigenvector, and then with every data point that comes in, it actually it enables you to move in that direction. Ultimately, you converge. Once you converge, you don't change the direction. Only thing is scaling, right? That's what we learned. Like I think
Right.
is not converge, right? So intuitively, this is what it is. Now, if you are a player who is farther away from that ultimate direction, of course, it will take you a lot more iteration, and plus others will steal your money. You'll lose, then your money goes to them. So you kind of
So this
don't.
is the same convergence that you're saying that we observed when we took a random vector and we input it to a matrix to see what is the uh, eigenvector we are going to get. So the closer it is to the that value, the less number of iterations it took for it to converge.
Yeah. So if you know the distribution, you know the optimal answer. But if you don't know the distribution, then you have to take more iteration to figure it out. That's why it's I think sir is here. So if the distribution is given, I mean distribution of how many times A will win or B will or C will win, then I think we pretty much know the direction, and we just need to. So it's very simple. Like see if we know the probability of winning for ABC, so let's call it P1, P2, P3. And my weights of my money, 1 lakh, is let's say W1, W2, W3. So whoever comes up with the sigma PI WI, right? P1 W1 plus P2 W2, maximize that subject to constraint. Of course, P1 summation of P1 is equal to 1, and sorry, yeah, and then WI also is equal to 1. I mean, those are the constraints. So
Charge device.
yeah.
Can you
Oh,
plug in your device as well?
yeah.
Yeah, why did you get that notification hibernating unless plugged in soon?
I
You
don't know.
get that, no?
I didn't get it. Like I didn't see where it is.
What laptop are you using?
Yeah. No, I usually get it, but this time I didn't get.
That's what you usually get that stuff.
Yeah.
Yes, sir. You're saying something, sir. So you were saying something about the distribution.
You're talking, yeah, I mean, so more I think about it, I'm not sure. More I think about it, it I think our job should be to invest in the optimal direction, not based on what other vectors are doing. I think the winner is decided based on whose cosine angle is least with respect to the optimal vector. That's kind of my intuition, but again, I think sir would probably tell us at the end, like what's the
And the cosine vector being least will lead to the maximal output. So
geometrically, I'm saying if I take two vectors, cosine means it's projection, right?
right.
If you apply a force, if my force is at a very small angle to my whatever is the desired direction, I'll get a maximum impact. The opposite is when I'm like orthogonal, because the projection is 0, right? So I'm not going to move anything on that direction, right? So that's the geometric or intuition behind that. So we pretty much know that we need to get closer, and convergence happens when we reach that hyperplane or that vector. So yeah.
Understood. Nishan, are you done with your code? Have you tried running it? Try running it if it's working.
I don't know if they're working exactly, but it's asking for inputs.
Okay.
Please share.
Yeah, Shriram, you can try running the code and tell us if it's working or not. I'll be back, guys.
There is two sharing of the screen happening, is it? I was always wondering how it is done in Zoom. Is it easy?
Yes, sir.
Oh,
It depends on
okay.
it depends on the setting if it is allowed or not.
Oh, yeah, yeah.
Yeah,
so
yeah, I
it
had.
change,
Yeah.
yeah. Okay, interesting. So we had to make a choice, which one to see.
Which one to see? Yeah.
Hmm.
As if life was easy. You know, multitasking at the screen sharing level too has started in life.
So this is the
Right.
fifth dimension.
It's very difficult. Hmm. In fact, if you have multiple monitors, you can see the different screens of different people.
Yes, sir. Yes, sir.
Like a channel now. So they should show a statistics out of all the viewers, who is watching what. That would be like our probability, which screen is winning.
Maybe we can use it for tomorrow.
Who's more popular?
Yeah.
It will be like the viewership of Super Bowl.
Yeah, actually, I'm watching Nishan's screen, and the round one is actually showing us.
Okay.
And I think he's only. Acha, okay, you are giving. How are you giving the input? Just
Manually.
Manually, I
oh,
guess.
you're just giving random input.
Yes, sir.
I think if
Nishan.
you follow a strategy, so what you
Nishan,
do, the previous round balance and multiply the strategy, then I think that you don't need to input. So it will kind of you'll show the message. This is what the investment was, and then you multiply. Then that will be.
Nishan, we have 3 companies, right? So what is the investment in each company by these investors?
Right. Showing right.
First of all, let us see the
We-
code. Now, what is the code?
We have a 3x3 matrix, right?
One second. This is the code.
Okay, so probability of A, B, and C.
It's asking for number of rounds to play.
Oh, so you have made it like a C is going to win half of the time. Interesting. So
Yeah.
that's usually hidden. See, if this is hidden, then you don't know the distribution of winning. If it is given,
So the
okay.
idea was so that we know what the probability is going to be. We know that part, and we have 3 people, and they have 3 different strategies. One investor's strategy is to invest close to what the actual probability is, not exactly equal to that, but close. Second investor strategy is investing away from that probability, and the third investor is going to invest equally regardless of what the probability is. And we wanted to see that which one is going to last. So the program will need to take investment after each round, Nishan, and there will be 3 inputs for company A, company B, and C by 3 users. So SMB, you'll have to modify your code for it, I think.
Okay.
Nishan, one thing that I don't understand is the investment in A, investment in just scroll down a bit, no? Make the terminal smaller.
Okay, I'll share the prompt that I just.
Yeah, this invest S, invest B, that variable is there, right? Above, yeah. This one, the invest S is investment by S on which company? The S will invest in 3 companies, right?
One second.
It should be a list of 3, I guess. 3 float values.
I'll rewrite the prompt. One second.
Okay. Yeah, take your time.
I will try to write a code as well. Let's see.
Okay, you use ChatGPT.
No, I'll use a Copilot for this.
No. I asked Nishan whether
Nishan wrote it with Copilot as well.
Okay.
I'm writing this.
Even for me, that error was there, so I had to correct it manually only. That's the thing.
Mm.
Okay, that's fine.
Can you correct me, Sriram, if something what modifications should I make for the prompt?
The
Like,
three investors S and B each will invest some proportion in company A, B, and rest will go in C. Okay. In each round, one company will be okay. Company will get all the winning company will get all the money. The money will be redistributed among the investors according to the proportion of okay. Like does the winning winning company, okay, sorry. In fact, that is not input from the user is also not required. You can ask it to, the strategy can be inside. So you can say that this person will invest this proportion of it in A, B, C. That's fine. Ideally, this is the same prompt. I don't know how. Okay,
So,
fine.
so we have to also give the prompt that these three investors, SM and D, have a strategy. So strategy of S is to do this, right? And then
Yeah, that also you're right.
this
Yes.
and D does this, right? So we have to
Investor S.
So we don't need the input, you just give the strategy. So you take the existing balance of S and invest in this proportion to these stocks. Investors have a strategy of their own. Okay, so S was sir, right? So sir, what did he say? He follows S invest 20% of his balance in stock A. And we'll say you add a little random noise to that, basically, right? Random vector. I think that's the Kalman filter idea, right? A little bit of noise, right? So invest 20%, 0.2 of balance in stock A. Uh, 0.30 in and rest in stock C. Rest in stock C. Stock C. Yeah. Ensure you add a little random noise to this proportion. So I mean for S, full stop, then you ensure add a random noise between 0.0 to what 0.01, right? So noise to between 0 to 0.2. So, to these proportions. Investment in A and B, right? A and B. The C will be rest, right? So C doesn't need to be specified, right? Okay. Please ensure this proportion of ABC add to 1, right? Because that's a constraint, right? Because sometimes they may, mess up the. Please ensure proportion of money invested in ABC all add up to 1. Proportion of investments in ABC. Of investments in ABC. Yeah. Okay, so the 3 bullet points are actually for strategy of S, right? Somehow we had to mention this is for. So maybe you put in that colon you have own, right? So call it strategy of S and then underline. So this 1, 2, 3 points are for investor S. Then we do similar for M and D. Okay, looks like. M is totally random, right? So generate a random number between 0 to 0.5 and invest a random proportion between 0 to 0.5. Invest. In stock A. Comma, a random number between 0 to 0.5 in stock B. You can copy paste the same thing basically. Yeah. Instead of number, call it proportion. So that way it's clear, right? Because proportion of his balance. Oh yeah, random proportion, fine. Balance. Total balance. Then within bracket 0 to 0.5. Something like that. I don't know. The prompt is also. And the rest in C, yeah. Point number 2 is not required now. Only, yeah. Because the random numbers, so that's not needed. Ensure the proportion add up to 1, yeah. That will be point number 2. And then instead of S, you have to call it M actually, because it is copy paste error. So M will invest. M will invest, whatever. Or invest, whatever, like if you want to talk about strategy. Must invest, yeah. Then investor D invests 1/3 of balance in each stock. I think that's basically pretty straightforward. 1/3 of total balance in stock ABC each equally. 1/3 of his balance in ABC respectively. Let's see. That's it.
I guess this is sufficient, isn't it?
Yeah. Oh, the investor is mistyped on the top actually. It says S, A, B, C, D. Yeah. Now we are doing 3 companies ABC, probability, SMD. B it says, right? It'll get confused. Each of these investors will invest some proportion in equity, and the rest I'm going to see each one out. Yeah. How many rounds you to say, right? How many rounds you going to play?
Hmm.
Right. Then way to describe what happens after each round, right? We haven't described that.
Fine.
I think I mentioned that on the top, but whichever company wins, it takes all the investment, and then how the money gets distributed. Okay, proportional invested in the winning company. Okay, I think it's clear. Yeah, let's run it. No
Oh,
results.
maybe we'll have to do it stepwise, maybe. Yes, it is way too complicated for study or Copilot. Hmm. Getting now. Maybe we can modify it. Let's see. Also not. इसमें पैसा बढ़ जा रहा है पता नहीं कैसे.
I I wrote a code where I explained the whole game to the GPT, and it wrote a code where uh, after each round the investment was zero. The whole prize money vanished. So I'm writing another code.
क्या फिक्स नहीं हुआ यार इसमें.
I tried using ChatGPT. It's not nearly
Hmm.
as close as this.
पैसा सही दे दिया ठीक है. डिस्ट्रीब्यूशन सही है तीनों का. 500 राउंड्स के लिए. Okay. So I must also mention this that the sum of S, M, and D earnings cannot exceed 30. That is. Hmm.
Oh.
I did it in Excel. Just to easy to visualize.
Pardon, sir, could you just repeat that?
I said I did it in Excel. We can see everything.
Okay, yeah. Maybe you can share your screen.
I had to log on to the other device. Let me just give you-
Okay, sure. Take your time, sir.
Okay, I think my code is also working, kind of.
Kind of.
I mean, like if we can like automate how to enter M's investment, then we can run it for like 1,000 iterations or 10,000 iterations also.
Hmm.
But just a second, I'll show what I got. Yeah. So here I just put random numbers, like random percentages here for 5 rounds for M. And investment of S and D were like constant. For S, we invested 0.2, 0.3, and 0.5. And for D, 0.3, 0.3, 0.3, and so on. So after 5 rounds, we can see that investment of S has gone to 98,000. Investment of D has gone to 1,49,000. And investment of M has gone to 52,000. So in mine also, Davis Smith sir is winning.
Interesting.
The equal one is winning, right?
Yeah, actually, I have
Yeah,
a
yeah, yeah.
simplified view in Excel, right? Just for, So what, Atharva, once you're done, let me know, then I'll share the Excel one.
Yeah, done.
Huh?
Yeah, I'm done.
Okay, let me share the screen. Hopefully you can see. Yeah. Okay, so what I'm doing is, this is the investment strategy. So there are 3 stocks and these are the investors, right? S, M, and D, right? So what we said was the theoretical distribution is 0.2, 0.3, and 0.5, right? So S would try to get something which is 0.2 plus some random noise. So that
Right.
rand by 100 is basically 0.01, right?
Mhm.
Similarly here 0.3 plus some random noise, which is 0.01, right? And then rest is basically 1 minus the previous 2. So that will be ensure the proportion add up to 1.
Right, correct.
Okay, so this is kind of our S strategy. M is Maria's strategy was between 0 to 0.5 and another random number between 0 to 0.5, and this one will be 1 minus the previous 2. Okay, so that is one, and then third was basically 1/3, 1/3, 1/3, right? So the investment strategy is clear, right? So it's a 3x3 box, right?
Yes.
So let's say round 1. So what I'm trying to do is we start with the initial balance of 1 lakh for each person, right? So sorry, balance of M actually, balance of D, right? So these 3 people start with 100,000 each. Now what I'm trying to do is investment in A. So what is my balance matrix, right? Starting matrix, right? So let's call it the B matrix. So these are the strategy matrix, right? S matrix. So what I'm trying to do is I start with my beginning balance of that round, and what I do is I multiply that with whatever is my strategy, right? So the row 3 is fixed. That means after every round, it will come to the row 3 and take that, right? So that means I get 1 lakh, 1 lakh. So these are the balances. Now here, what we do here is this is a player view. This is what the player or investors are doing. Now I take a row view, which is a stock view. I said, okay, fine. Now I know this much money was invested by 3 players in these stock A, stock B, stock C. So this is the row view. So the 3 lakh investment was distributed this way along 3 stocks. So what I'm trying to now do is what is the proportions invested in each stock, right? So I'm taking this 20,000 invested by A by the total investment in A, right? That means 26% of investment in A came from S, 32% came from M, and then 42% came from D. Clear? So
Hmm.
basically it is taking 20,000 divided by 79,000. That's what the formula is.
Right.
Right? Then this one is saying 25,000 divided by 79,000, 42,000. And then I have a checksum here, like should be the row. This is basically saying that it is a row.
Summing up over right.
Okay. So investments are being made on columns, but this proportions are being this. Then what I do is I generate a random number. Right? Now, who is the winning stock? I'm saying that I generate a random number, and if this random number is between 0 to 0.2, A wins, right? Remember the CDF, right? So if A's winning probability is 0.2, then A wins. Then if B wins, then any random number between 0.2 to 0.5, because remember the probability of B winning is 0.3.
Right.
That means if I generate enough random number, if the random number falls between 0 to 0.2, we'll call A as the winner. The random number is between 0.2 to 0.5, we'll call B as the winner, right? Then rest C. So that means if we follow this strategy, if we do it 100 times, C will win half of the time, B will win 30% of the time, and A will win 20% of the time, right? Got it? Clear on this part? Then our job is, once we know who is the winning stock, we have to pick up that particular row. So I'm using VLOOKUP here, right? So what it does is, it takes whoever is the winner. I'm trying to search for that row. So this B16, I'm actually going to do here and then kind of pick the second column. So that comes here, 26. A is the winner, get 26. This is what I pick. Same thing, but third column. And this one is fourth column. Okay. So you can clearly see if A is the winner, it's picking this 3 matrix. Right? Now, once I know that, all I have to do is compute the balances, right? So I know the balances are basically the winning stock gets all the balances. So this 3 lakh rupees now has to be distributed according to this proportion to these players. So
Correct.
this is basically ending balance or new balance. So all I have to do is basically 26% of 3 lakhs.
3 lakh, 32%
That
of 3 lakh.
means, so S basically lost money,
Hmm.
M also lost money, and clearly D won money
Right.
in this round, where A actually was the winner, right? Okay. Now let's play the game one more time. So I basically literally copy pasted. If you notice, I'm leaving 2 rows here. So what I did here is, basically I'm referencing this. So ending balance of round 1 is the beginning balance for round 2, right? So it's just a straight, reference to 2 rows above. So I start with that. Now here I had to make sure I follow the same strategy, right? So what I remember, I froze row 3. So
Right.
whatever happens, right? In every round, it will do some random number and then it will kind of generate that, right? Okay, so the only thing is here in Excel, every time you click, everything keeps changing, right? So essentially you are kind of, but again, to understand what is happening, I think it will help us to understand the row. At least it brings a lot of transparency as to what is really happening, right? So let's say in round 2, again, you can see that, these are the opening balances. The investments were done according to this strategy. So you can see clearly this total matches with the balance. So it ensures that it is done. And this is the amount of investment in A, B, C. So these proportions are also 1. So this constraint is valid. This time the random number became 0.23. So you can see the winning stock is B. You can see this row is getting picked, right? Now the 3 lakh is getting distributed like this, right?
Right. So if we repeat this a more number of times, we want to observe what will happen to the investments made by S, M, and D. We want to see that.
Yeah. So if I notice here, if I look at the now copy the balances, 1 lakh for S becomes 1 lakh 6, then becomes 1 lakh 9. So clearly S is going the increasing direction.
Right.
M is going from 1 lakh to 79.
Decreasing.
No, sorry, 1 lakh to 79, 79 to 61.
Correct.
So S is kind of going down.
Right.
And for D, 1 lakh becomes 1 lakh 14, becomes 1 lakh 28,
Attains a plateau afterwards.
right?
Then starts decreasing, is it?
Correct. Now let's play the
Right.
round 3. Right? So we're playing this game again. All I have to do is copy the entire block, leave 2 spaces so that way it's very clear. And these are my check digits to make sure that the proportion add up to 1 and these things are done properly. That's how I got the referencing. And here it is actually here winning stock is C. So yes, this got picked up. This is correct. Now it is getting distributed like this. So what happened here? 112 now. So here actually it decreased, right? So here, and then round 4, this time B1. So it picked up this, which is correct. So now it is 122. So what we have to do is then round 5. I haven't copied here, so I can't do that. But the point is, but one thing is for sure, right? If you notice here what is happening, the
M who invested
M
away
is
from the
1 lakh.
probability.
Yeah, it's kind of 47, 35, 26, very interesting,
Declining.
right? And look at the S,
Right.
continuously increasing, right? And
Correct.
one thing I would say is the D would always remain around at the middle point, 1 lakh, plus or
So
minus.
my question is that what happens? So we'll need obviously more data for this, but the question I have is what will happen? So it's clearly visible that B is going to get out of the game after some time. So what will happen afterwards? So once B is out of the game, what happens to S and D? So which strategy is the most optimal for winning? Is it S's strategy or D's strategy?
So I don't know. Honestly, I don't know.
Right.
Honestly, I don't know. I mean, I kind of intuitively, I see this expectation is when you don't know, you take a uniform. That is the
Right.
hunch. I didn't derive it anything mathematically. When you don't know anything about data, you just place your bets evenly, like I thought,
Right.
right? So, but in this case, I think, other time the known winning percentage was not given. Like if I know C is going to win more, maybe I would have bet more on C instead of, one third, one third, one third, right? So,
Right.
yeah, so that was kind of guess, but again, every player has its own strategy. So let's actually, I don't know,
Can
let's
you
see.
simulate some more rounds, sir? Maybe
Correct,
10 to 15 rounds. I'll
correct,
try
correct.
to edit my code as well till then.
Yeah. So all I have to do is just manually give like
Mhm.
round 6 here. And if I leave to 189, yeah, it's clearly, then leave two more places, round 7. And yeah, very interesting.
Actually, in my code also, for first 10 rounds, I'm getting randomly, any one of the three will have higher income, sorry, higher balance. So sometimes S is having higher balance, sometimes M is having, sometimes D. But when I simulate that 10,000 times, I'm getting that D is having 3 lakh in his bank balance, M is having 0, and S is having like e raised to power minus 287 something, so
Basically
very
zero.
low.
Basically zero.
Yeah, but why is D having all the balance? Like, shouldn't S have all the balance?
I don't know. So maybe you can mm, share. I'll stop sharing. Maybe you can otherwise share your screen and show what I mean.
Yeah. So this is what I'm getting. Okay. And there, yeah.
This 0 0. So
But
But this is
investment of
equal investment.
but
D, yeah, yeah.
S also loses, right? It's e raised to power minus 317 if I'm
that's
not.
basically zero. That's
Yeah,
basically,
yeah.
Yeah.
It is 0.
yeah.
So D is investing. D was investing equally, right?
Yeah, yeah.
Okay. Let's write another code. I'm trying to rectify my code as well. Yes, sir. This session
Yeah,
is.
if someone can just take a look at this code, maybe.
Okay.
I'll
So explain us what we're doing here. Okay, so first your total money ABC is 0, initializing it. Okay. Then balance for S and D is 1 lakh. Yeah, that's your starting money. You start playing the game.
yeah.
Then you have invest.
Now,
Okay.
Atharva, can you please upload this on that Replit? Maybe it will be easy for me to go through it.
uh,
And
I'll
everyone.
put it on GitHub. I'll put it on GitHub if possible. So,
Okay, fine.
What's the time now? 11. Okay.
Yeah, I've shared my code on GitHub.
Is it working?
Yeah, it is working, but it is giving that the equal investment one is better.
Okay.
So if you can just review it if it is correct or not. Maybe.
Yeah. Shriram, is your code working as well?
Yeah, mine is also working.
And what's your result that you are getting?
The equal one is only winning. The person who is investing equally is winning.
And same is the result for you, Athama, right?
Yeah, yeah.
Okay. Interesting. 200, 300. And Devasmith sir's result was the person who was investing away from the distribution was losing, and the two people, one investing closely to the actual distribution, and the person investing equally were winning compared to the other person. So we couldn't actually see what will happen once one person loses. So we'll see that as well.
Was it? No, I think it was just it was just a random fluke, I think, because in
Okay.
like uh, when I reduce like number of rounds in my code, it is giving a random winners.
Yeah. Even for me, that
So
happens.
it's like a what you call a convergence, right? You do sufficient. So the intuitive what I'm thinking is, let's say the strategy of applying the same percentage of investment as for the distribution, right? So if I 0.2 multiplied by probability of winning is also 0.2 if I do some sufficient simulation, right? So what is the expected payoff or balance? 0.2 into 0.2. So it's 0.2.
Okay, so my code is working fine now. I have rectified my code. It seems that okay, let me share my screen. But for this, we'll have to uh, enter the investments in each round. So if I, is my screen visible to everyone, guys?
Yeah.
Okay. So say S, so the probability is 0.2, 0.3, and 0.5, right? So say S invests somewhere around 210, uh, 320. I mean, this is not the optimal way to for the code to, I mean, for us to write the code, but this was the only thing that I could come up with. So say it will be what 470. Right. So 470, and the second Maria's investment was away from the distribution. So say she invests 300, 200, and 500, let's say. And D's investment was 330, 330, and 340. So after the first round, this will be the returns that they will have. So um, for if the company B won, so the amount that was it will get is 320. It is 320 divided by 850 times 3000. So 1129.41. So that's the amount it's getting. Some try I'll modify the code so that we don't have to enter the amount each time for D and S, since they are following some sort of uh, pattern there. So I'll modify the code for that now. So is your have you tried for the other rounds as well? For more rounds for in Excel?
Devaswita, what result are you getting by Excel sheet?
I haven't actually because every time I do, the random number is changing in Excel, right? So what I'm trying to do is I'm sending the random number, copy pasting as values, and keeping a winner, so that way it will become steady.
Right.
So that is why that's
Okay,
the
okay.
yeah. So I'm actually working on that because then it will be easy to visualize, right? So
Sort of like random dot seed.
yeah, so then I'm going to copy paste the value, so it will not change. But I'm also doing a distribution to ensure that it is actually random, right? It's
Right.
not
Right.
random, right? So
Yeah.
maybe one thing about Excel is easy to visualize. That's all, right? Nothing.
Okay, I kind of added a graph also to this code, so we can see that what is happening.
Okay.
Yeah. Is my screen visible?
Yeah, it is.
Mhm.
Yeah, okay, nice.
So
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 you're
I think
saying
it's something like that.
Clearly see that D is not.
150 iterations, you're done.
Yeah.
150.
I
No,
wanted to
this
actually
we are.
verify the code, so because if I remember correctly, if I recall correctly, so I was mentioning that the best strategy to invest is to modify your investment according to the probability. Uh, so that's the
Yeah.
best. But here, the person who's winning is the person who invested equally among all the companies, regardless of the probability. So I actually want to see if the other codes give us the same result or not.
Yeah. If possible, someone can just go through my code also. I've put like GitHub link.
Mhm.
So
Yeah. Ankit, is your code working?
No, but chat, no, it's not working as I am expecting it.
Okay, I'm modifying my code as well. Let's see.
I got the Excel thing to work now.
Uh, how many rounds have you simulated, sir?
I just have to copy paste, that's all. And I got up to um, around 14.
Okay.
Yes,
And
let's actually let Atharva finish, then I'll
sure.
explain what I'm doing.
yeah,
Sure.
I'll just.
Okay, I'm going to delete that to ensure that
Mhm.
I repeat it. Okay. All right. Okay, I'll share the screen now. Share screen. All right. Okay, so what I've done here, for simplicity, I'm calling it this one round. There's a investment strategy, right?
Right.
Because the random numbers were changing, what I did was I kept all the strategy in a different tab.
Oh, okay,
And
nice.
I kind of pre-populated up to around 25. It can be expanded, but anyway, just thought.
Right.
Right. So what is A strategy? A strategy is to generate a random number 0.2 and add a random
Some
one,
error with that.
right? So I did that rand and all that. So and
And
so you can clearly see if I plot these investments over rounds,
Right.
Just 1 second. If I say insert chart. You can clearly see. This is the investment strategy. So more or less 0.5 for stock C, more or less a random noise. It's like the Kalman filter strategy, right? Right? Something like that, right? So this is what it is for S. Now, if I want to go and plot the strategy for M, so what M is doing is M is doing
Randomly.
random number. So I believe the first where is the first series? Okay, so this blue is the investment in stock A. Okay, so blue is the first random number. Then
Orange is the
orange is
investment
the
will be
one, and then whatever is the rest is basically the gray.
correct.
So all these three will be. So you can clearly see the highest is like these two are low. So then right. So I've done a check digit, so that way it's kind of add up to 1, right? So that is 1. And then let's see. Okay, now let's say for this is
For it's pretty straightforward, right?
okay. All right, very straightforward. So what I have done, so you can clearly see that this code. Now then after that I copy pasted as values. So that way it will not change. Right. So basically the strategy is prefixed for all rounds, right? So that is my strategy. Secondly, there's a random number who is the winner, right? Also another simulation that I'm doing. So what I did was I said, okay, I did round 1 to round 25. Then I did a random number generator, right? And then if this random number is less than 0.2 A wins, if it is less than 0.5 B wins, and otherwise C wins, right? And I wanted to prove that this is indeed true, right? So I did a pivot table and refresh. Indeed, out of the 25 simulation, C is winning 56% of the time, 32 and 12. So roughly, because this is basically panned out, right? So if I do maybe and like this, say expand like this, and then copy, paste the values, and then let's refresh it. Oh, what happened? Why did it change? Yeah, this is C, this is B. It should not change actually. 1 second. Yeah, correct. A bit surprised that the random number generator should work. So roughly 20, 30, and 50, right? So we know that. So that means we have basically pre-decided who's going to win based on the round. First round will be A, second will be C. So remember how Sar was saying, right? I think Ankit was doing that, right? Round 1, somebody going and I have already created a sequence unknown, but it's generated through random number. So now I've fixed it for the first 25 round. I know who are the winners, winning stock, and then obviously this proportion is validated across 25. Right? So now I go back. So what I'm trying to do is here I created a variable in column K called round number. And you can see that it's kind of going to get incremented. So, by 1 every time I run the game, right? So poor man's way of writing a Python loop, right? So this part is done like round. So then what happens is, so here, if you look at it, it will go to the strategy column. And it will look for these K7, which is this one. So for round 1, it will look for in column B3 to G6, which is here, B3 to G6, which is B3 to 6, right? So this is for strategy of S, right? Depending the 1, it will actually do a H lookup and it will pick column 2. Column 2 is essentially nothing but row 2 actually, 2, 3, 4. Will basically become the investment or proportion for those stocks. That is what I have here. So this is row 2, row 3, and row 4. Well, row 4 is basically 1 minus that, so right? Similarly,
Right.
for what do you call it? For
For M, it's random. The first column you copied from there.
okay, now for M, actually, I should also do the same.
Mhm.
What I should do is instead of that, instead of yeah, K7 will be fine. Instead of searching in 3 to 6, I should search from 10 to 13. And to 13. And this is for row 2. It will be for row 3. So we can just validate in round 1, was it
Mhm.
2642? Yes, 2024, right? So essentially I'm copying this, right? You can validate
Yeah.
that like this. This one
Is
actually
again going to be 1 by 3. Any
so here there's no need to even look up, but anyway,
Right.
so it's right. So okay, so now we have that. So then this part was pretty clear, right? You know,
Mhm.
all it
Right.
does. So this time I'm not doing any dollar amount, just doing relative referencing. So you can see that 100,000, 1,000, and this proportion is basically based on column E.
Mhm.
Okay, so these all add up to 1. Now A was the winner for the first one. So I'm picking this, right? And now the money is distributed this way, right?
Mhm.
Now what happens? I leave 2 rows and I copy the thing again. So now it becomes round 2, right? So let's copy these things here, okay, just to ensure. Right. Yeah, it's picking round 2. Now we can check if S was 208830094903. Yes, 49 60 35. 49 60 35 15 20. So it's actually very easily verifiable that it's working. And then D is this. So this is copying from here and all that, right? So after round 2, I can clearly see S started with 1,77,98,124. Then C1, then 120, 47, 132. After round 2, let me copy this. I'll leave 2 rows. This is round 3, 111, 54, 133. Round 4, 1,52, 139.
Investment for M is decreasing. Okay.
M is decreasing. Round 5, round 6,
Okay.
round,
M is going to. Okay. Interesting.
round 8,
Staying afloat.
round 9, round 10, round 11. You can clearly see now it's like you
Correct.
see
Correct. If it goes below 100, we'll consider it a goner.
okay, I can safely go up to round 25 without breaking my spreadsheet, right? I can theoretically go, I just have to,
Mhm.
but let me actually exhaust it. So 30, 19, 20,
I don't. Okay.
20,
Staying afloat is.
22, 23, 24, 25. So we can clearly see what's going on here.
Another interesting thing is that if you observe, M went down to 1,000, but
Okay.
again started. Yeah, it went down to 1,000 somewhere in the investments.
For 47, then 52. Okay, here it actually gained a little bit.
Yeah,
Then it went down to 22, 14.
14,
Then it
19,
increased 19,000. But then 7,
7,
4.
4, 1944, and then it started gaining again.
Right. Gaining.
Very curious what's happening.
Then 10, and 17, then 9, then 2, right? So, but generally, so basically what's happening is the graph that Atharva was saying, right? So there is this noise, but then there is a secular, the trend is going down, the average is going down, but there is some variation around that, right? So it's like, so curve could be going down, and imagine there's a curve and then you have added random noise. So it's kind of
I-
like stock price. If you
We'll
go
need
long-
more simulation
I
for this, sir. We'll need more
yeah,
simulation
I
for
think we
this.
need more simulation.
Right.
Pardon?
Because like I'll show one graph that I got. It
Mhm.
has like for at least 100 or 150 rounds, it has S more than D. But
Right.
after 150 or something, D has shot up and like it has gone straight up to
Okay, why
3
don't you
lines.
share actually, Atharva, that would be nice.
Yeah, good. Atharva. Share your screen. I will try to modify my code as well till then. Ah,
Yeah.
very interesting.
So in
No,
this
very
case, we can see
interesting.
like yeah, for at least 100 or 150, D is
150.
greater than S. S is greater than D, and then there we get here.
So
Right.
remember the convergence of sequence is what you call the dragon, the tail of the dragon is most important. That's where the energy is, right? So when we are looking at the sequence will converge in the tail.
Hmm.
So initially, it's kind of will hover around and finally it will converge.
Very interesting. Okay. I think if is anyone else working on anything? If their code is working, can we have something we can actually verify this result with? If the other code gives us the same result, then we have the result.
So Atharva, your result and my results are exactly opposite of each other, right? So
Right, exactly.
right. Because in my
No,
Excel
no. In
simulation, S was winning. Then D
no,
was
in
second,
this case,
and M was losing
no,
miserably.
So
yeah,
in this case also,
in this case, our results are matching. But for a higher number of rounds, D is suddenly going up. So now in your case, we have
Okay,
considered
I
like
did it
25
at
rounds, right?
25.
M
Okay.
is still going down, sir. M after
Mhm.
I think 10 or so investments, 10 or so round, M actually went down to zero, almost zero.
Okay, so we agree on M. So there's a point
Yeah.
of what do you call, like,
Conflict for S and
inflection
D.
point. There's an inflection point where the green line crosses the blue line, I think around 100 or 100 plus, right?
Right.
Okay, so
Just a second. What are we like? What is the strategy of M? I have taken that M invest randomly, like random
Right.
percentage of their money.
Correct.
Yeah. So that is the right strategy, no?
yes,
Like
random strategy.
for
No,
M.
no, I mean, yeah, for M it's the right strategy, but for the game it's not.
Yeah.
Uh,
Like I was just checking that if that's how M was supposed to invest.
S is supposed to be investing very close to the actual probability. M is supposed to be investing randomly, very away from the actual probability, and D is supposed to be investing equally regardless of what the probability is.
Yeah. So I think like if someone is free and like they can check the code, maybe if there is
Uh,
some like
I'm
error or
actually working
something.
on my code as well. I don't know. It will take me some time. I think I'll figure it out. I'll work on
Yeah,
it.
sure.
Okay, I will go through the code
Yeah.
and give my feedback. Random, interesting. Okay, total money. Balance. One more thing I see, Athava, in your line 101, sorry, 198. You're saying winner with equal probability, ABC. Line 98. Athava, you're on mute if you're saying something.
Oh, I was saying, how did I miss that?
Yeah.
Just a minute, I'll fix that. I mean, now it makes sense that it should, like, D should only get richer, right? Because we are splitting it equally.
Yeah. In some sense, now we know. Actually, so the D is winning because it is to the vector. So it kind of makes sense. It's very
Yeah,
good.
yeah,
By mistake, we have also discovered something, so essentially it goes down to
yeah,
the
yeah,
point I made that whoever is investing in the cosine distance of that vector with the true vector, whoever has the minimum angle will actually.
Okay, let's try now.
You can share your screen.
Okay, okay, now S is winning. S is winning, S is winning. Great. I feel
Well,
stupid now.
S is winning.
Yeah, yeah, yeah.
Hey, can you show the plot? Very interesting now.
No, actually, what I did was
Equal
I
probability.
like chose A, B, C with equal probability. That's why D was winning.
Can you show the plot now? What's the
Yeah,
plot
yeah.
now?
I'll just yeah.
Now
I'll
we have two methods telling us the same result, right? Giving us the same result. Stupid mistake. Fix.
yeah. Okay.
Fix.
So here S is winning, D is going down.
Right. So the best strategy is actually investing according to the probability of what we have seen so far. Very interesting.
Okay. Yeah.
Or no, not so far, very close to the actual probability. But the, now the part comes, how do you figure out that actual probability? Mm, Since
Yeah. What's
So what will happen is, let's say you don't know the answer, right?
right.
Say A is 0.2, B is 0.3, and C is 0.5 is given. Let's say you
Mhm.
do, right? So what will happen is every time some stock is winning, at least that result is announced, right?
Correct.
Very similar to, like, let's say and you keep track, right? Round 1A, round 2B, round 3C. And every time what you do is, for all the known results, essentially data that you have observed, you start doing the frequency of the stock winning, and divided by the total number of rounds will give you the PDF, right? So I'm going back to the stats too, right? So you start with the prior, then you start observing data. When you multiply the prior with the observed data, then you basically get your likelihood function.
Right. So the problem there was one thing that we observed in one of the probabilities, with one of the probabilities is there were three companies, A, B, and C.
Yeah.
For first 14 or say 18 rounds, company B was winning very frequently. So what we thought was till that point that, okay, company B is winning, so the probability seems to be higher. And some of the investors invested according to that. After that point onwards, the company B seemed to be not winning at all, and company A and C started winning more frequently, and that changed the whole probability distribution in the favor of company A and C. So that actually, I think, that actually made Atharva lose a lot of money, right, Atharva? So it
Yeah,
seemed
yeah,
that that probably wasn't the best approach. So that was my concern. That how do we figure out what is the actual probability? I mean,
See, maybe one thing we should learn is, let's say we don't know the probability, right?
Mhm.
Let's say A winning probability is P1, B is P2, and C is 1 minus P1 minus P2, right?
right.
So if I take 100 runs, how many times would you see A winning? Let's say it's 20, 30, 50. You will see 20 A's, 30 B's,
Mhm.
and 50 C's. So let's say we put all these coins into a box, shake it, put it on a line, and then just draw a line, right? It's just random, right? So what I'm saying is unexpected. If I have length L, I would say 2/10 of that, I would see some kind of a winning. Those many proportional positions, right? So if I kind of randomly fill these runs with some dots, then you would see, 20% A's and 30% B's and 50% C. Half them would be C, right? Now that basically tells us the PDF. Now the sequence in which they appear is basically random, because remember, what is the probability of, so first position can be placed with three different ways, second is three
Right.
different ways, third is three. Now, of course, it's 3 to the 50, but obviously not everything will follow the PDF, right?
Correct.
So this is why the probability that you give a very random, like what is the probability that you will see 5 A's winning in a row is actually
Mhm.
less,
Mhm.
right? Because it's like a geometric, right? So this is why if you've got a weird sample, I mean, that's like a very less chance of occurring. But eventually, if you run the experiment a lot of times, those A winning consecutively 5 times, very, very less, right? For example, if you look at India winning all the matches 10 in a row, how many teams have won 10 matches in a World Cup? Now the condition part is, what is the probability of winning the World Cup given that you had a 10 wins in a row?
10 wins. Very low.
So if you look at it, if you are you're not a Bayesian, it doesn't matter. Prior doesn't matter. Prior data doesn't matter. The whatever happens tomorrow is a random draw. It's 0.5. India winning is 0.5. But if you go to the history and say, okay, if I look at the conditional probability of winning the cup, given that you had won 10 matches in a row, suddenly, there are like 10 World Cups and all that, and it has happened very less number of times. Whenever it happened, the team which was the dominant team won. Maybe Australia of 2003 and 99,
Three.
two
Right.
instances. You'll get probability of winning is 1, right? So
Mhm.
this is kind of how the same data, if you are allowing the past data to interact with that, changes your worldview, right? So I don't know, maybe another way to think through what's going on here.
Okay. I think our both the results actually tell us the same thing, that the best strategy to win is to invest close to what the actual probability is. Otherwise, either you'll lose in the very first rounds or after a couple more rounds. But you're doomed to lose if that's the case. Okay, I think that was the
That's
aim for today's session.
Other
Yeah,
questions?
that's the same as making your this investment vector coincide with the probability vector. Yeah.
maximizing your return.
No, maximizing return is done, but that is achieved when your investment vector is coinciding with your
But that's when
probability
you are
vector.
maximizing your return, right?
Yeah.
That's what it
Actually,
means
this,
by
this
maximizing the
conclusion,
return.
this point actually came yesterday in the discussion,
Yeah.
and
Mm.
I message some of if the session is finished, you can stop the recording.
Yeah, let me stop it.